Hello again. You're back. I'm back too. Um, I just wanted to fill you in on what you missed yesterday, which was October 15th. That's 10/15/2020. In class, briefly touched on what we did. We ended up doing another activity. We went through the slides. I encouraged you at the end of the last video to go through the slides yourself. That's still, once again, another parameter I want to set. But in so doing, I'm actually going to show you again how to get there. I said it, and it should be obvious, but there's a couple routes to take. I'm going to give you the simplest route. First thing would be to go to your Google Classroom page, and you'd want to go to what makes sense. Obviously, you want to go to Google Drive, and that's where it'll be. You can go to Google Drive, and you could have added it as a shortcut, or either way, it's in your Shared with Me section. If it's not in your Shared with Me, or you did not add a shortcut, then go to your Google Classroom. Go to Classwork, and there are two buttons you can click on. One will get you straight to Drive, the other one will take you straight to the Class Docs folder. If I see up here where it says Class Drive, that will take you to Google Drive. Click on it. Once again, this is a tutorial on how to get to the slides. Yet again, it's a multiple tutorial. Now, this is the folder made. It's made automatically for the Google Class. This isn't going to do what you want it to do. This takes you to Drive. Probably the simplest way, if you don't have a button along your bottom row of your Chromebook. Anyway, then you want to go over here and click on Shared with Me. And yours will look a little bit different, but your Shared with Me, you should have in this general area, it should be a folder that says Night Chemistry Class Docs. If not, either way, we have an alternative set up, and it is to go down to Resources. I'm going to move it to the top just to eliminate all guesswork. Make it work right. Resources should be near the top. You click on Class Docs folder, and you click on that folder. It'll open up in Google Drive the Class Docs folder with every slide, every set of slides, and most of even worksheets. It'll pop up like this. Here's mine, show tiles. I like to have mine be lined items, so I have clicked up here to turn it from tiles and into line items. Either way, bonding is where we're going. And then you just click on the logo that's the slides logo, right? It says bonding class notes. I wish it were more evident than that. If it's not, you probably have a view that looks like this, in which case it's harder to tell the full title. It still says bonding class notes pretty evidently, but anyway, you click on these lines and you can change it. Double click on that. That's your slides for this unit, and I want you to walk through it. Let's see what slide to begin on. Where I'm from yesterday, 10/15, where we touched on, and then we went to an activity for the entire rest of the time. The activity is supplemental. The inquiry activity that I went over yesterday in yesterday's video really is kind of double dipping. The reason it's to double dip is so you can see the actual theory that our methodology was based on. So we had methodology we did in the other activity, the inquiry activity, where we took the oxidation numbers that were brought and then we swapped them to get the subscripts. That is made possible because of the theoretical idea that's going on, saying that an ion that is negative has a negative attraction and therefore wants to bond with the positive thing of the opposite attraction. So that's kind of we demonstrate that with little pretend atoms. I'll show you real quick. We do it with these little pretend atoms right here. Those are pretend atoms, and they have valleys and peaks, similar to the way negative and positive ions would have negative extra electrons or give away extra electrons. Anyway, so when you go to the slides, you've got the foldable here that we went through already. You've got the practice we went through already. Got another video, we did not watch it, and then yesterday we picked up right here on slide 26. I want you to present this thing as if it's in class. Present, go to present mode. Press Control F5. Yours is going to be different because it's a Chromebook. Anyway, go to present. Walk through that set of slides, and just go through all of them. As of today, as of 10/16, we will have gone through every single bit of them. Now, I'm going to show you me scrolling through them, and I might say a few words here and there about what we're going to do. But more than anything, the most important thing is to go through these slides yourself and ask questions as they may arise. So it looks like a couple formatting situations are going on, but that's okay. I don't think that happens very often. We just know the plus sign should be next to the number, like an oxidation that we're supposed to read. So when this transferred over from PowerPoint, it just looks a little bit different. But you should just be able to understand what this is showing you, what this is demonstrating, and follow it along. If you have questions, of course, save those, bring them up to me. This is frustrating. And send me in the remind, send me in a chat, message, whatever it may be. Get your problems squared away that you have, because this is where we're going to be when we're going to be here when we through this when you come back. So make sure you're doing your due diligence. And what I like to say is that if you care more, it'll matter more. And if it matters more, then you'll do these things. It's just the bottom line. So if you care, it'll matter. If it matters, you'll do the right things. So, and you'll keep trying. You'll be resilient. So that's kind of the bottom line here. But there are your slides. You need to walk through them. You need to, they don't show the names here, do they? We didn't practice these in class. These were self-revealed, so we can kind of just showed you, demonstrated for you how they were named. Oh, you gotta be kidding, come on. Anyway, it shows you the names themselves in greater detail, and I don't know why they wouldn't be there like they ought to be. It just didn't transfer over. Anyway, I might be updating these slides soon then, but one way or the other, there the slides are. They're in the Google Drive. You have no excuse not to find them. So just stick with them, be diligent, do what you need. And anyway, we're going to flip through the slides here as well on your behalf. So you can always watch this like a video and simply pause it at the moments that you need to. Because like I said, I'm about to click through it. So we just talked about predicting ionic charges. This was practicing what you already did in the inquiry activity, where you just go and try to guess, oh, group 1, that's a 1+, because they lose an electron. And this is what they look like when they're written in their ion form. I also made the distinction that 1+ is an oxidation number. So if H+ here is the ion for hydrogen, it has a 1+ oxidation number and a +1 charge. And I would ask another student in the class. So group 2, 2+, remember to pause or slow down as needed. 2+ oxidation is a +2 charge. Group 13 or 3A, lose 3 to become 3+, that's oxidation number or charge of +3. Charge is +3, oxidation number is 3+, you write oxidation numbers as superscripts for the ions. Group 14 is neither, they rarely form ions at all. Group 15 gains 3 electrons, 3-, and they are given names. They're replaced with I that goes in and does the step for you. And so on. Like I said, I'm about to go away for a minute and let you just watch these slides. I really want you to pause it as needed. The bottom line is, though, go watch these slides yourself. This was the part that was formatted out for some reason. This just re-practices the naming rules. Shrink me for a second. Practices the naming rules again. Pause it if you need to. Practices the formulaic rules. Points out some key details like this is the cation, the anion, and the subscript. Remember, from math, underlined numbers are called coefficients. In chemistry, those underlined numbers are still coefficients, but the circled numbers are now subscripts, and they tell you more about the numbers. This means there are two hydrogens, and there are 2 in this compound, H2, and there are 2 H2 compounds. So in total, that would be 4 hydrogens. But understand, the 2 coefficient says how many compounds there are. The 2 subscript says how many H's are in the compound itself. Then we did this practice, had students make this notebook paper, look like this, format it this way, and then we did a little activity where we took bonding possibilities, and if we picked an ion to make a bond for, like sodium and chlorine, if it made a legal rectangle and it was only 2 types of ions, then we wrote it down like this: sodium, chlorine, ions. I don't list any, even if I use more than 1 chlorine to form a compound, chlorine is still a 1- charge. Sodium's still plus. I do the same method from the day before. I crisscross their oxidation numbers and write them as subscripts. The 1 subscript doesn't have to be written, and then I give it a name. Calcium is another example here. I'll move that up, move it out of the way. If I take calcium and I write it down, I can then take oxygen and write it down as the ion I choose. It's O2-. It says -2, that's a typo. It should be 2-. Anyway, I write that down, and then the formula, I can do 2 things. I can crisscross my superscripts, my oxidation numbers, and they reduce to 1 and 1. But also I can, this is part of this lab, what it does is it demonstrates that there's 1 oxygen ion, 1 oxygen, and 1 calcium ion. So that would be your subscript also. You could count the number of pieces you use. I'm literally using 1 piece of each. So that's a 1 subscript for each. Just interesting. Then potassium, it would require 2 of these to satisfy the oxygen. See, I have an open spot. I need to go into my bag and get that other K out right there and match it up to this spot. And that'd be 2 Ks, so that's subscript of 2, and 1 O, so O subscript, and I name it potassium oxide, and so on and so forth. And we would use all the possibilities of ions in this bag to form every combination possible. There would be 30. I post these rules up there. We set our goal to be 30. So see the first one you got there, we get a prize. No repeats. No more than 2 elements per compound. So if I could use 2 potassiums and 1 oxygen, but I couldn't use a potassium and a silver and an oxygen. That'd be 3 elements used, only 2 elements total, and there's a total possible setup of 30 salts. Interesting combinations come up whenever you get the incongruent mixes. For example, if I were to do aluminum and oxygen, oh no, it doesn't work. I got to finish the rectangle. So I would actually add another oxygen right here, which would leave another peak over here. So I'd add another aluminum, which would leave 2 valleys. So I add another oxygen, and I end up having 2 aluminums, 2 aluminum, and 3 oxygens. And then I'd write those subscripts subsequently. That's the one tricky piece. But it's actually not that tricky. Anyway, that's set up to get you there. If you want to take one of those home later, I can give you one of those when you arrive back. We're not going to spend much more time on that because we've got to move on. But we're going to move through the rest of the slides. And so I'm going to leave you for now to finish watching the rest of the slides. It's going to be on the video, but you should also go watch it yourself so you can go through your own pace, you can formulate your own questions, and let me know what questions you have. Thank you for listening. Thanks for watching, and I will reconvene with you later. Have a good weekend.